In the last question, we're asked to determine the resultant force and the reaction force of the track on the marble. So let's begin with a free body diagram. We know that at the top of the track, there's the force of gravity pulling downward. But this marble wants to go in that direction, and it doesn't because there's a normal force pushing in the same direction. So what we know when we apply Newton's second law is the net force, of course, is the sum of the forces. And the net force we observe is causing centripetal acceleration, and that is Fn plus Fg. They are both working in the same direction to produce the centripetal acceleration. Well, MAC is mv squared over r, and that is force normal plus mg. And the normal force that we are looking for is then mv squared over r minus mg. The mass is 0.05. The velocity given to us was 3. And the radius is this height, this total height, which was 0.35. It's half that, the radius. So it's 0.35 over 2. And that is minus the mass, 0.05 times 10, the gravity. So we have this first term, which is the centripetal force, which is 2.57. And we have this 0.05 times 10, which is 0.5, which gives us a normal force of 2.07 newtons. Now we could check ourselves. We can come back and say, let's do a check here. And let's see then, does the net force equal the sum of the forces? Well, the net force is the centripetal force, force normal plus the weight. And the centripetal force is 2.57. The normal force 2.07, and the force of gravity 0.5. So 2.57 does in fact equal 2.57. And that is part 4 of this question.